So in point 5, we move on to discuss some of the more critical studies which were launched to try to prove the Keyes hypothesis. So I think it's really important to make the point that many of these original studies were not really designed to disprove Keyes. They were driven by people whose goal was to prove the diet-heart hypothesis. And the reason simply was because there was so much money in the business that it was rather easier to support Keyes and his ideas than to conflict with him. Because I suspect if you decided to take on Keyes, you'd lose funding, because that was how much control he had over the American Heart Association and the National Institute of Health, who were the premier funders. So in the early 1960s, Keyes did his first randomized control trial, the Minnesota coronary experiment, which was a remarkably good experiment in which, as I'll show you, he changed the diets of certain institutionalized patients, and it was meticulously done. The problem was that the study disproved his hypothesis, so the data had to be hidden. Those data were then subsequently recovered, and that we call the recovered Minnesota coronary experiment. And then that exposed the so-called Sydney diet-heart study, which was also recovered, and that also showed that the data had been hidden because it disproved his hypothesis. And then the Women's Health Initiative, which I go into in some detail, a $700 million experiment, which also disproved the low-fat diet. That also had to be hidden. The findings had to be hidden. And so that's why most people do not know anything about these three trials. And I'm going to go through them to show you that these trials are terribly important. And in my opinion, they prove that it's unethical for anyone to remove saturated fat, to be told to remove saturated fat from their diets. So that if you're a clinician and you advise people to replace saturated fat with polyunsaturated fats, these three studies show that's unethical because it'll do harm. Now the studies were hidden, and that's why people don't know about them, because they were meant to show the opposite. And as soon as they produced evidence that conflicted with Keyes' hypothesis, there was only one solution: they had to be hidden. So the first of these trials was the Minnesota coronary experiment, which was done by Ivan France Jr. Interestingly, Keyes was the premier researcher, but his name doesn't appear here, which is really interesting. But he drew up the trial and he raised the funds for it, but his name doesn't appear. And that's something that I've never understood why that should be. This study was completed in 1976, and the data were presented at a cardiological conference, presumably the American Cardiological Society, in 1976. But the data were only published in 1989. And remember, 1976 was 1 year before the McGovern Commission released its findings. So the question is, what was the impact of this study not being published in 1976 and only being published in 1989? So here was the trial: a large number of men and women living in Minnesota mental institutions. Half were assigned to a diet with reduced content of saturated fat, and the other half were assigned to the diet with the same total fat but with more saturated fat. Now notice, this is not a low-fat diet. This is a diet high in polyunsaturated fats. And this was therefore not a study of the low-fat diet, which was the one that we're told to eat. This was of replacing saturated fat with polyunsaturated fats. Subtle but important point. So here is the intervention diet and the control diet, and they had the same amount of total fat, but much less saturated fat in the intervention, much more polyunsaturated fats, pretty much the same monounsaturated fats, and much less cholesterol. And so this trial then went for about 5 years, and subjects were followed for 4.5 years, and then the results were reported. But the data were known in 1976, but they only get reported in 1989. And here was the graph published in 1989, and you can see on the left is the percent of subjects, both men and women, without events, and you can see it looks pretty much the same. But on the right is a survival curve, and if you look carefully, you'll notice that the survival curve for the control group is better. And so at the end of the experiment, there are more people alive on the control diet than in the treatment diet, and the change seems to occur after about a year and a half. That's where the two lines start to differentiate. And remarkably, there were more deaths in the treatment group than in the control group. So anyone looking at this graph, as I've shown it to you there, would have to say these are not equivalents. The treatment group are doing worse than the control group. But that was not how it was reported. And it said, although the study did not show a statistically significant reduction in cardiovascular events or total deaths from the treatment diet. Now, why would you say that first? Why would you say, although it didn't? Why wouldn't you just say these are the results? But they don't. And that's the problem with all these diet studies. They're trying to make sure that they always prove that the diet works. So therefore, if it doesn't work, it's a surprise. So then the authors suspect that it might have shown such a reduction if the period of treatment had been longer in persons in the age range likely to benefit. We included persons of all ages, both men and women, with an average cholesterol concentration of 207 milligrams per deciliter compared to much higher values in other clinical trials. So what you notice in all these trials is that the authors will always tell you why the study didn't find what it was expected to find, but that is not science. Science is you test an hypothesis. If the data don't fit the hypothesis is wrong, and you start all over again with a new hypothesis. But I'll show you this is something that these researchers could never do because their funding was so dependent on them finding for the diet and then continuing the funding sources, because anyone who found opposite to that would lose their funding. So there's no way they were going to chance their careers and end their careers by finding in favor of a diet higher in saturated fat. Well, eventually Dr. France died, and his son, who's a medical doctor, was going through his house, his father's house, and discovered all the records from the Minnesota coronary experiment. And he decided to get in touch with Dr. Ramsden, who he knew could analyze the data, and he sent them to Dr. Ramsden. And then Dr. Ramsden went through them and produced the recovered Minnesota coronary experiment data. But this was what the interview Anahad O'Connor wrote at that time in 2016 when the data were first reported. So what was the result? Despite being one of the largest controlled clinical dietary trials of its kind ever conducted, the data were never fully analyzed. And that's absolutely true. It was a brilliant study. It was very well conducted. The younger Dr. France said his father was probably startled by what seemed to be no benefit in replacing saturated fat with vegetable oil. When it turned out that it didn't reduce risk, it was quite puzzling, he said, and since it was effective in lowering cholesterol, it was weird. Well, it was only weird according to the model that predicts that cholesterol causes heart disease by saturated fat causes heart disease by raising blood cholesterol concentrations. That's the only model in which it's weird. If you're a proper scientist, when you see something is weird, you say, well, the hypothesis is wrong, we have to change it. One would expect that the more you lowered the cholesterol, the better outcome, Dr. Ramsden said, but in this case, the opposite association was found. The greater degree of cholesterol lowering was associated with a higher rather than a lower risk of death. And he then published, Dr. Ramsden published the Minnesota coronary experiment, the recovered Minnesota coronary experiment, and here was the major finding of that study, that if you were over 65 years, you did much worse if you were on the diet. And so you can see the cumulative proportion of deaths was increased in the linoleic acid group compared to the control group. And so he concluded, or they concluded, the intervention group had a significant reduction in serum cholesterol concentrations. They dropped 14% versus only 1% in the controls. then Kaplan-Mayo graphs showed no mortality benefit for the intervention group in the full randomized cohort or for any prescribed subgroup. However, there was a 22% higher risk of death for each 0.78 millimole per liter reduction in serum cholesterol. In other words, the more the cholesterol fell, the worse the outcome. There was no evidence of benefit in the intervention group for coronary atherosclerosis or myocardial infarctions. So that was the KEYS study, the Minnesota coronary experiment. The data, as I've said, should have been published in 1976. They were only published in 1989, which was long after the dietary guidelines had changed the guidelines and said we should eat more polyunsaturated fats. And the point is, as in an interview Daisy Zamora said, if this study had been published in 1976 when it should have been, i.e. 1 year before the Dietary Guidelines Committee of Senator McGovern had come up with their new guidelines, they couldn't have produced those guidelines. Because people would have said, but hold on, you've done a clinical trial, it disproves your hypothesis, how can you now force the Americans to change their diets on the basis of a diet which we now causes harm? It couldn't have happened. So that's why this study was so important that it should be suppressed. So he further concluded, Dr. Ramsden then went and looked at all the studies of polyunsaturated fat substitution for saturated fats, and he said the available evidence from randomized controlled trials shows that replacement of saturated fat in the diet with linoleic acid effectively lowers serum cholesterol, but does not support the hypothesis that this translates to a lower risk of death from coronary heart disease or all causes. And then he warns that findings from the Minnesota coronary experiment add to growing evidence that incomplete publication has contributed to overestimation of the benefits of replacing saturated fat with vegetable oils rich in linoleic acid. I would say it's worse. It's not just an overestimation of the benefits, it's an exclusion of the evidence for harm caused by this substitution. So the next study to be recovered was the Sydney Diet Heart study, which was started in 1966, and the early publication came out in the 70s. And here's, of course, the Sydney Opera House, and it says here the Sydney Diet Heart study ended in 1973, the same year when the Opera House was opened. And then it took another 40 years before the real evidence from the study was published, and again it was the recovered Sydney Diet Heart study. So here's the original study. 458 Sydney men, middle-aged men with heart attacks, were randomized. Half were assigned to a reduced saturated fat diet and half were assigned to a self-selected dietary behavior. They basically could just continue to do what they like. And the intervention group replaced dietary saturated fat from animal fats, common margarines and shortenings with omega-6 linoleic acid from safflower oil and safflower oil margarine. So again, this is not a low-fat diet study. It's a study of replacing saturated fat with polyunsaturated fats. The control group were just told to keep eating, but they could replace butter with margarine if they so wished, which is interesting because that shows that there was already accumulating pressure for people to eat margarine instead of butter. And they were studied for 2 to 7 years. And here's the paper of the outcome, and it's published in 1978. There we have it, published 1978. And this is the conclusion. Survival was slightly better in the second group. Now that's really interesting, because which was the second group? It was the control group. He didn't say survival was slightly better in the control group, because that you'd have to read the article to know which was the second group. But if it said control group, then everyone would have known. Multivariate analysis showed that none of the dietary factors were significantly related to survival. Prognosis was determined largely by the extent of coronary and myocardial disease, as judged by the usual clinical parameters. Recreational physical activity had a strongly favorable influence on survival, and I'd argue that's probably associational. In other words, the healthy people are the ones who are more likely to survive and more likely to be exercising. It is concluded that because of multiple changes in lifestyle, men who have had myocardial infarction are not a good choice for testing the lipid hypothesis. And they explained because weight loss, reduction in cigarette smoking, increases in physical activity, and other readjustments may well have more important beneficial effects than changes in dietary lipids. So again, it's another explanation why they didn't find what they wanted to find. Well, here are the data. So this comes from the original article in 1978, and it shows that survival in the control group is somewhat better than in the intervention group. And here's the problem. There were 28 deaths in the control group, but 37 deaths in the experimental group. So that may or may not be significant, but it has to mean something. That there's clearly no benefit in this diet, and there may well be harm. Well, the harm was eventually identified by Christopher Ramsden and his team, who did the same on this study as they did on the Minnesota coronary experiment. And they produced then 3 graphs of comparing the intervention versus the control group survivals for all cause. That's all cause death rates, and you'll see the death rates are higher in the intervention group. Cardiovascular disease, cumulative death rates, again, they're higher in the intervention group. And coronary heart disease, cumulative death rates, again, higher in the intervention groups. So far from showing that there's no difference in the trials, this actually again showed that the polyunsaturated fats were harming the patients. And here with increased risk, if you were taking the intervention, 62%, 70%, and 4% increased risk. The risk is not great, again, because the risk is relatively small. So a large increase in risk doesn't actually reflect much change in risk to the individual. So Ramsden concluded, in this cohort, substituting dietary linoleic acid in place of saturated fat increased the rates of death from all causes, coronary heart disease, and cardiovascular disease. And then he included an updated meta-analysis of linoleic acid intervention trials showed no evidence of cardiovascular benefit. These findings could have important implications for worldwide dietary advice to substitute omega-6 linoleic acid or polyunsaturated fats in general for saturated fats. And that evidence has not been acted on. We still get the advice that we must replace saturated fat with polyunsaturated fats. But the trials which were meant to prove it proved the opposite, yet the public isn't told it. Then the third study, which is important, is the Women's Health Initiative, randomized controlled dietary modification trial between 1993 and 2005. And again, I'll show you that this was a very expensive study. This was the study that was going to prove that the low-fat diet prevents coronary heart disease, apart from many other things. It was going to be the Nobel Prize-winning study, and it was the final answer that the National Institute of Health and the American Heart Association were going to prove that they'd failed. The other studies had failed because they hadn't done enough. They hadn't have enough subjects, and they hadn't done a good enough intervention. So here was this trial. Listen to it, 48,000 postmenopausal women, 40 assigned to a low-fat eating plan, and 60% were just allowed to continue eating what they chose. The 40% now reduced their fat consumption from 20% and from saturated fat to 7%, and they increased fruit and vegetable intake to at least 5 servings per day and grains to at least 6 servings per day. So this was a test of the American Heart Association Heart Healthy Prudent Diet. Very important to remember that. This is a test of the diet that heart disease patients are told to eat. And it's a modern study, 1993. A lot of the complaints about the other studies that they were dated, but this is a modern study. So the poor old control group were just told to read the dietary guidelines for Americans as well as other health-related material. They had no contact with anyone, whereas this group had sometimes monthly interventions. So can you imagine organizing monthly interventions for all these people over a period of time? And then they were studied for 8.1 years. So this is an incredible study. It's unbelievable. If anything is going to prove one way or the other what the outcome is going to be, it's this study. So here's the study reported by Dr. Howard in 2005. And the conclusion was that the study did not significantly reduce the risk of CHD, stroke, or cardiovascular disease in postmenopausal women and achieved only modest effects on cardiovascular risk factors, suggesting that more focused diet and lifestyle interventions may be needed to improve risk factors and reduce CVD risk. Or perhaps what the authors couldn't consider was that the intervention is simply ineffective because it's based on the wrong hypothesis. So one of the main organizers of this was Dr. Jacques Rousseau, and his comment was, "This study shows that just reducing total fat does not go far enough to have an impact on heart disease risk. While the participants' overall change in LDL bad cholesterol was small, we saw trends towards greater reduction in cholesterol and heart disease in women eating less saturated and trans fats." So this is a post hoc justification for why the study didn't prove what you wanted to prove. But actually, Professor Rousseau, you don't understand. If you understand the null hypothesis, you'll acknowledge that your team spent $700 million disproving the diet-hard hypothesis. Trying to justify that your study would have found in favor of the low-fat diet if only you'd spent another $700 million forcing your study subject to eat a zero-fat diet is post hoc reasoning. Proper scientists understand that the best approach to a study that disproves your own long-held beliefs is to acknowledge that you are wrong. And that, unfortunately, is something that's not possible for most of the people involved in these studies. The head of the National Institute of Health at that time, Professor Nabel, added her story. "The results of the study do not change established recommendations on disease prevention. Women should continue to work with their doctors to reduce their risk for heart disease, including following a diet low in saturated fat, trans fats, and cholesterol." Which is utterly astonishing. They might as well not have done the study, because the study is not hypothesis testing, it's purely used to advertise the low-fat diet. And what I've learned from reading these people's stories is that they will always, when they present the information, they will give the impression that the study worked. And they'll never say, actually, we were completely wrong. So actually, no, Drs. Nabel and Rousseau, the study disproved your null hypothesis. In real science, when the hypothesis is disproven, we have to come up with a new one and then attempt to disprove it. Science does not prove hypotheses. What I discovered in my debate with Professor Rousseau, the week before I had the debate, I was directed to the key to his study by Dr. Andreas Ehrenfeld, who's of course so well known as the diet doctor. And he said, "Did you see this statement hidden in the middle of the article?" And it says the hazard ratio for the 3.4% of the women in the study with cardiovascular disease at baseline was 1.26. What that means is that the risk of having a subsequent cardiovascular event, if you started the study with heart disease, was 1.26, was 26% higher if you were on the intervention diet. So the intervention diet caused harm to those people the women who started the trial with heart disease. And that's exactly what you would expect. If the diet is harmful, it's going to harm the people who are most at risk. And those who are most at risk are those who have already established heart disease. So if the study had included, let's say, 20% of people with established coronary heart disease, then you might well have found that the diet was harmful, and it would have been more obvious and they couldn't have hidden it. So it's entirely predictable, as the high carbohydrate diet produces all the things we know: hyperinsulinemia, hyperglycemia, and hypertriglyceridemia in those who are metabolically vulnerable, as they are insulin resistant. So this is the canary in the mine, that the canary dies from carbon monoxide poisoning before the humans die. And these were the people who were most likely at risk. So I went then to look at the data, and what I discovered was, if you looked at this particular table, there was an anomaly on it. So generally, if we look very carefully here, we'll see this is people taking statins, and it says statin use no or yes, and then it says there was no difference. It didn't favor the intervention or didn't favor the comparison whether or not you took statins. So let's look at this. This would be yes, I'm taking statins, and it didn't favor the intervention, which was taking statins. So there was no benefit for taking statins. But that's not the point, because when we look at the diet in those people who had heart disease, we notice an anomaly. And the anomaly is that when we look to the left of the slide, we see a no, but there's no yes. So in other words, there's no report of what happened to those people with cardiovascular disease who had a history of cardiovascular disease and were on the intervention. It's not included. And then we look to the right and we notice that this dot is sitting here when it should be lower down. So there's something wrong. There's a line of text that is missing. And this is what's missing. The missing is the yes. And what happens is then you'll see, if you were on the diet, that's this dot now comes down here, and it favors the comparison. In other words, those people who were with a heart disease and who were not taking the diet. They were the control group. So in other words, if you had a history of cardiovascular disease, yes, and you were on the control diet, you did better than if you were on the intervention diet. Now that was missing from the data, and I pointed that out to Professor Rousseau in this article and suggested that he should change that and update that article. But that's not happened, and this is now 15 years after that publication. But it didn't end there, because the low-fat diet was also prescribed for people with diabetes on the trial, and it found that women with diabetes at baseline did experience adverse glycemic effects of the low-fat diet, which indicated that caution should be exercised in recommending a reduction in overall dietary fat in women with diabetes unless accompanied by additional recommendations to guide carbohydrate intake. And that's nonsense, absolute nonsense. What they should have said was that women with diabetes at baseline need to be warned that if they replace dietary fat with carbohydrates, their diabetes will worsen. So why can we not tell them the truth without such circumlocution? How could your conventional advice possibly be wrong? And that was the reality. They wouldn't admit that the conventional advice was wrong. So the Women's Health Initiative proved that if you were sick because you had heart disease or diabetes, and therefore you were the canary in the coal mine, you were at much worse risk if you followed this diet. And no one ever reports that data.